Hi everyone, we're going to sketch a graph of the polynomial function and also by using the x and y intercepts and also the end behavior of the polynomial. So in order to find the y-intercept, that is when x is 0, that's your y-intercept. So I'm just going to plug in 0 everywhere there's an x. And what happens, this all zeroes out. So my y-intercept is just 0, 12. Now to find your x-intercepts, that is when y is 0. So this is like your y here. We can just make that y. So we're going to do y equals, and I'm going to factor this. And I'm going to factor this by grouping. So the first part I'm going to do is factor out an x squared. And when you do that, you're going to get 2x minus 3. And this should not be an 18. This should be an 8. All right, and then I'm going to pull out a negative 4 from this part. So that's going to be 2x minus 3 as well. Don't forget to change this sign to a negative here, because when you multiply negative 4 times a negative 3, that gives you a positive 12. So then I would factor by grouping, so you get x squared minus 4 times 2x minus 3. I can factor completely. I'll do a difference of squares here. X minus 2 times x plus 2 times 2x minus 3. So this has 3 x-intercepts. If I set this to 0, we're going to get 2 here, negative 2 here, and 3/2 here. So that is when y is 0. We have 2, negative 2, and 3 over 2, 1.5. All right, so now when you look at this equation again, and we have y equals 2x cubed minus 3x squared minus 8x plus 12, we know that our degree is 3. So it resembles, our power function is basically, you just write this 2x cubed. But it resembles the graph y equals x cubed, our parent function. So if you graph that and look at it, the only reason we're doing this is get the end behavior. So I know this quadrant is positive, positive, and this quadrant is negative, negative. So if you're reading the graph left to right, we're going to be starting in quadrant 3, ending in quadrant 1. And therefore, just looking at this here, that means as x approaches positive infinity, my y approaches positive infinity. Then we look at this for quadrant 3, as x approaches negative infinity, y approaches negative infinity, because these are both negative. All right, so we can try to graph it. I went by the scale of 2 here. I have a y-intercept at 12, at negative 2, and at 2, and where else was it? 1.5. So we go back to 1.5 right here. All right, so what we're going to do is start. This is going to be skinny here. We're starting in quadrant 3 because of our end behavior. And go through our x-intercept, go all the way to the y, come back down through here. And then this little bit here, we're just sketching it. We don't really know our min and max, but then come back through here. So we did start in quadrant 3, and we ended in quadrant 1. And that's basically your graph. We had your turning points. If your degree is 3, and that's your n, then your turning points is at most n minus 1. So in this case, it would be 3 minus 1, which is 2. So we have at most 2 turning points, and we actually do have 2 turning points right here, and right here it turns back around. Okay, that's all. Thank you. Have a nice day. Bye-bye.